So we come to the next part of mole concept only. But now we want to deal with charge. You are aware what is the charge present on one electron? E minus is a symbol. We'll be using it for electron. You know what is the charge present on electron? 1.6 into 10 to the power minus 19 coulomb. Then what is the charge present on 1 mole of electrons? 1 mole of electron means 6.022 into 10 to the power 23. Cross multiply. That is 6.022 into 10 to the power minus 19 multiplied by 1.6. Sorry. It should be 6.022 into 10 to the power 23 multiplied by 1.6 into 10 to the power minus 19. Now, if you multiply this and this, approximately it is 9.65. And if you multiply 10 to the power 23 and 10 to the power minus 19, you will get 10 to the power 4. If you open up, that is 96500 coulomb. So remember, charge present on 1 mole of electrons is 96,500, which is popularly remembered as 1 Faraday, in the remembrance of the great scientist Michael Faraday. You should also, as a student, should know charge on 1 electron and charge on 1 proton is same. It is 1.6 into 10 to the power minus 19. 1.6 into 10 to the power minus 19. In case of proton, it is positive. In case of electron, it is negative. Okay, what is 1 Faraday? 1 Faraday is a charge given by symbol 1F. Is a charge present on 6.022 into 10 to the power 23 electrons, or you can say charge present on 1 mole of electrons is remembered as 1 Faraday. That means you should remember, if you multiply Avogadro number with charge of 1 electron, you will get 96,500. That means charge of 1 electron and Avogadro number, if you multiply, you will get 96,500 coulomb, which is remembered as 1F, or you want to write down, you can write down 1 Faraday with F as a small symbol. Henceforth, wherever you come across 1.6 into 10 to the power 23, remember it is 96,500 coulomb or 1 Faraday. What is the charge present on 1 calcium ion? It is due to loss of 2 electrons. You know, 1 calcium atom has 20 protons and 20 electrons, and therefore has 0 charge, because number of protons and number of electrons are equal. But when you say 1 calcium ion, protons number will remain same because nucleus remains unaffected, but electrons will become 18. So electrons will become less. That means now there will be 2 extra protons present inside the calcium ion. So therefore they will have a charge of 2 multiplied by 1.6 into 10 to the power minus 19, because this is a charge present on proton and you are dealing with 2 protons, and then you will have a plus factor because protons have plus charge. So 1 calcium ion has a charge of plus 2 into 1.6 into 10 to the power minus 19. So what do you expect charge present on 50 calcium? Yes, you will multiply by 50. What does that 50 stands for? 50 stands for number of calcium ions. 2 stands for that extra magnitude of the charge present on the calcium ion. And you can remember this is still the charge of 1 electron, and we write down plus because it is a positive ion. So from this we got a general formula. What is a general formula? Charge on n particles will be n multiplied by the factor. Factor for calcium 2 plus will be how much? Factor for calcium 2 plus will be 2. What will be factor for N3 minus? It will be 3. What will be factor for hydroxide ion? It will be 1. Are you understanding what is that factor? Is the magnitude of the charge present multiplied by the charge of an electron or a proton. If it is a positive ion, then plus. If it is a negative ion, then minus. But now instead of dealing with n particles, if you are dealing with n moles, then what is the formula? Then n moles has how many particles? N mole has n multiplied by Avogadro number of particles. So in the place of n, now you should write down n multiplied by Avogadro. So number of particles present in n moles is n multiplied by Avogadro number multiplied by factor multiplied by the charge present on electron or a proton in coulombs. Now if you remember Avogadro number multiplied by charge of 1 electron. Charge of 1 electron or a proton is 1.6 into 10 to the power minus 19 coulomb. This is the charge present on 1 electron or a proton. If you multiply by Avogadro number, do you remember anything? Avogadro number multiplied by charge of 1 electron is nothing but 96,500 coulomb, which is 1 Faraday. Are you able to see? Right, Avogadro number is getting multiplied by charge of 1 electron. So if these two factors are multiplied, what is the number you get? Yes, 96,500. So what is the charge present on n mole of particles? Is n number of moles, Na, and 1.6 into 10 to the power minus 19. But this two multiplied number will be what? 96,500. If you want, you can write down this as plus or minus n multiplied by F Faraday, because 96,500 coulomb is 1 Faraday. 1 Faraday. So the F here stands for Faraday. Now we'll actually apply for a question. Find charge present on 2 moles of nitride ion. So in nitride ions, in this question, what is the moles? 2. What is the factor? That is the charge present on this in magnitude 3. So what is the formula for a charge in coulomb? N multiplied by factor multiplied by 96,500. And why minus? Because you're dealing with negatively charged ion. If you're dealing with negatively charged ions, you have to write down minus. So in the place of N2, factor 3 multiplied by 96,500 coulomb. That's the answer. If you want, you can write down this as 6 Faraday. If you remember, 96,500 coulomb is 1 Faraday. So you can write down minus 6 Faraday. We'll try to see slightly different question. Find the charge present on 8 gram of O2 plus ions. First, you should know what is the moles. Take the mass, divide by the molar mass. Mass is 8. And what is the molar mass for 1 oxygen? 1 oxygen, the mass is 16. Remember, you're not dealing with O2, you're dealing with a single oxygen. So value is 0.5 mole. What is the factor? What is the magnitude of the charge present? Yes, 2. What is the formula for charge? In coulomb. N multiplied by a factor multiplied by 96,500. But why you are writing positive? Because you are dealing with positively charged ion. So what is the number of moles? 0.5. What is the factor? 2 multiplied by 96,500. If you solve, you will get plus 96,500 coulomb, or you can write down 1 Faraday. How to write an answer depends on the way the question is asked or the way MCQ is asked. That way the answer will be done.